All the world, what it needs and whenever it needs is only one thing of which it is created of, the energy. Dear students, let us understand what kind of energy are we talking about when it comes to electron. So, energy of the electron in the stationary Bohr orbit looks something like this, like this, like this. Alright. So, according to Bohr's postulates, electron revolves in the nucleus in a circular orbit. Agreed. So its motion is in the field of positive nucleus. It has two energies. Why? It is moving, it has kinetic energy, and if it is attracted to nucleus but not going inside the nucleus, that means it has potential energy. Ladies and gentlemen, total energy can always be bifurcated into two parts. One is your kinetic and another is your potential. How to find kinetic? It is half mv square. Of course we know it. Just like radius and velocity, even we have to find energy from Bohr's postulate. So mv square, mv square, mv square. Where will you find mv square? Bohr's first postulate. In Bohr's first postulate, mv square by r is equal to 1 upon 4 pi epsilon 0. E square by r square. I want half mv square. Hello, r gets cancelled. I multiply by half, I get my kinetic energy, I am happiest. So what is my half mv square is equal to? If you calculate it, it's nothing but E square upon 8 pi epsilon 0 r. Simple and easy, no complication. Now, this is my kinetic energy. But when I talk about potential energy, the electric potential at a distance r from a charge E is given by. What is the formula? Potential is that 1 upon 4 pi epsilon 0 q upon r. In our case, q is equal to E. So potential energy is equal to charge into potential. Charge is E, and with minus sign because it is electron, it is negative, and nucleus is positive. And potential is 1 upon 4 pi epsilon 0 E upon r because that E is positive. So if I multiply both of them, what I get is potential energy as, this is the formula. Now I want total energy. So what I will do is I will add both of them. Once I add both of them, I will do some common thing, and after taking something out common, total energy is equal to so and so formula. Simple and easy. So this total energy, is equal to minus E square upon 8 pi epsilon 0 r. Well, that relation was with respect to r. But I want electron energy of nth Bohr orbit. That's called stationary orbit. So E of n is equal to this formula which I got just now. R on the other hand is n square epsilon 0 upon pi me square. I'll put the formula of R in this equation, and after putting up, I will cancel it many terms if possible, and I will get this kind of formula. The negative sign signifies that electron is bounded to nucleus by an electrostatic force of attraction. Electron is saying, please, 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 somebody take me out. And nucleus says, no, you belong to me. If you want to go out, you have to give me some kind of energy. So electron is in thirst of energy. When we talk about thirst of energy, it wants an energy. And because it wants an energy, it's a negative sign. So let's say the electron of nth orbit is minus 10 electron volt. I have to give plus 10 electron volt to get it out. Okay, what will happen if I supply 20 electron volt? Electrons and photons chapter. Any which ways, when I talk about energy, it is to do work on the electron to make it free from the atom. Okay. This minus me raised to 4, 8 I epsilon 0, all these things are constant. So, what do we do about constant? We just keep it out and we say energy is inversely proportional to n square, where n is principal quantum number. The energy of the electron is inversely proportional to n square, matlab it is not just a linear or non-linear relationship, it is more than negative sign. As you go up, energy goes on increasing, not decreasing, because of the negative sign. Now, for n equal to 1, energy of first orbit is equal to minus 13.6 electron volt. Okay, so for nth orbit, it will be E1 upon n square. How? I simply took the ratio. Okay, so En is equal to minus 13.6 electron volt into 1 upon n square. So, this entire idea of energy, when applied to the electron of the hydrogen atom, I get this formula, and that formula is minus 13.6 upon n square. You put n value as anything, you will get a general formula. These energy are also called as quantized energy level. Though the formula is a little little bit tough, but dear students, I'm pretty much sure you will master the art. So in this chapter, remember three formulas: radius, velocity, and energy. See you soon in my next module.